Okay. So we have this wonderful discrete probability distribution. And like I said earlier, I'm going to get rid of all this and I'm going to redo it really quick. So the first thing that we did was the the opponent 3-point field goals made. So we put that right there under rows. So we have a list of all of the ones that are made. And then I'm also going to put it right here. So this right here says some, but we want to change it. Like I said, we changed it from some. We want it to be the count. So it shows a count of the number of teams that scored that many 3-point field goals out of 183 teams. And then next, once again, we've got to drop this into values again, and we're going to change this show values as or summarize values. First, change it to count, and then summarize values by, or show values as percent of the grand total. Now, we grouped it by just going over to the row, right clicking and clicking group, or if you go up here in the pivot table analyze, you can click on the row labels and then you can do group, ungroup. So group field 1 down to 17, and we're going to group it by 3. And so when you group these, what we have is we have grouped data. Okay, group data is a little bit harder to work with, but we work with this type of data all the time. So we have 3-point field goals made. Okay, and then we are going to find the midpoint, and then we are going to we've got the number of field goals made, the probability of making, so we'll get to that in just a minute. So what's the midpoint of 1 to 3?
1.5.
So let's do equals 3 plus 1.
Or 2, sorry.
There we go. Oh, no worries. 3 plus 1 divided by 2. So that gives us the midpoint, right? So just 2. And then what are we looking at here?
5.
5.
6. Or 8, sorry.
And then 11, 14, 17. Now, the reason why I have this right here is because, say for instance, I didn't actually have all of these broken up in between. I could ungroup these again, but so often we have it broken up like this because it's so much easier to read than this massive long chart, right? And does this still give us a really good picture? This right here gives us a really good picture of what it is that we're dealing with. Okay, so we've got the midpoint, and then we've got the count of how many are made. Okay, which it really should be right here. Let's just do count, and I'm going to get rid of this right here. And then the probability of making those field goals. So what we have is the probability. We've got this probability right here, Control C. We're going to do that right there. And we've got the probabilities. There's another way that we could have done this. What's the other way that we could have done this? Instead of just copying it from the pivot table, if we didn't have this information right here, how could I find the probability?
It would be using the discrete formula that we have on the sheet, right? Or the number. Sorry.
Oh, no, you're fine. I don't know what discrete formula you have on the sheet. Which discrete formula do you have?
It's would be the numbers over the total, right?
Precisely. Exactly. Yeah. So we've got the total, which is going to be sum. And we're going to add up everything, all of the counts. So there's a total of 183. So exactly what you said, what we're going to do is we're going to do equals 37 divided by 183. And I'm going to put a $ sign right here. and I'm just going to drag it down. And you'll notice it's the exact same, right?
Mhm.
Okay. Now from here, we have this group data. Why are we using the midpoints again? Did I say that already?
No, but I assume so. It's uh, kind of like what we do for the weighted average, right?
Right. Precisely. So for the weighted average, and so same thing, it is our best guess estimate, right? Our best guess estimate. And because we don't know how many are ones, we don't know how many are twos, we don't know how many are threes. So we're just going to take the midpoint because it's the best piece of information that we have to estimate, this range. This is the best estimate of this range. This is the best estimate of this range without any additional information. Okay, and so from here, we can just do, we are going to put the midpoint in as n. Let's wrap this. Um, and so we've got, hold on. Yeah. Uh, we've got equals n multiplied by the probability. Okay. It really should say probability of n, but it is what it is.
Mm.
Um, and so we are going to drag this all down. And so this is essentially the contribution to the weighted average. So if you do equals sum, okay, the average team already did that, right? So
Mhm.
now we're going to do n minus mu. So this is mu. Equals n minus mu. And we're going to, what did I just, did I do that right? Yes. Okay. Equals this squared. And then once again, equals the probability multiplied by the squared. And then when you sum it all up, that gives you, what is this right here?
The variance,
The variance. Okay, so what do I have to do next to get the standard deviation?
square root it.
Equals square root. Okay, and so now you've got the square root, which is going to be a little different. Is it a little different than if we were to have had it all out, like all of the individual observations?
Yeah.
So, but it's close, right?
Yeah.
Okay, so how do you feel about what we just did?
It feels good. It makes sense.
Okay, questions about this at all?
No, I don't think so.
Okay, and when you get to your exam, what
Mhm.
I'd suggest is when you get to a question like this, which I don't think, I hope I don't have any questions. I might, I don't know. I've got to take a look. That require you to calculate a midpoint. But this, in all honesty, is one of the most beneficial skills, being able to work with group data, because you work with group data so much in your life.
Right.
And so no matter what you're going into, you'll work with group data. So this is really close. It's not as good as, if we were to have all of the information,
Mhm.
but this gives you the variance and the standard deviation if your data is grouped. Okay, questions, comments, inappropriate remarks?
No, I don't think so. Or actually, yeah, it's not so much about computation,
Mhm.
just about for use. So if we're in the future working with this kind of data, um, do we need to make a mark by our calculations if we've grouped it afterwards? Like, do we need to make a note of that with like our standard deviation calculations? Or
Um,
will it be assumed that we've grouped the data?
So I will tell you to group the data if you're supposed to group the data.
Okay.
Normally, you shouldn't ever group your data. If you're making calculations and if you have the raw data, use the raw data.
Okay.
But for instance, when you get into market research data, when you get into any kind of like data that is published, like if you go onto like statistica.com or whatever, they're not going to give you the raw data. They're going to give you group data. And when you get the group data, you've got to go in and say, okay, I've got this group data. Now I want to get the standard deviation. I want to get the variance. I want to compare this information. But how do I do that with group data? And so you can get so much data for free that's grouped. But yeah, when you want the raw data, you normally have to pay a pretty penny for it. So does that answer your question?
Yes, it does. Thank you.
Raw data is so much better than group data, but group data is what you're normally going to be stuck with.